In this section, we'll learn about total allowable error and how it can be calculated for a test. The TEA formula also consists of three components: z-score, imprecision goal %, bias goal %. We'll examine each of these components in more detail. We've already learned what the z-score is. The z-score value that's chosen to calculate the TE is the same one that should be used to calculate the TEA. To calculate for the imprecision goal %, there are two key pieces of information that are required: published biological variation data within subject, the performance goal for imprecision that the laboratory wants to achieve. First, how do we determine if there's published biological variation data for a test? Two resources are Appendix 1 of Dr. Callum Fraser's book, Biological Variation: From Principles to Practice, the Biological Variation Database hosted on Dr. Westgard's website. The database is maintained by Dr. Carmen Ricos and her colleagues. Once it's been confirmed that there's published biological variation data for the test, the performance goal for imprecision needs to be chosen by the laboratory. The approach that's going to be discussed here is based on the work of Dr. Callum Fraser, a leading expert in the field of biological variation and its application in the clinical diagnostic laboratory. There are three performance goals from which the laboratory can choose: minimum, desirable, optimal. The choice of a performance goal is linked to specific formulas for calculating allowable error. The outputs of these formulas are specific performance targets, traceable to the chosen performance goal. They're represented as a numerical value expressed as a % that defines the limit for imprecision and bias. A minimum performance goal is intended to be used for those tests for which technology is not yet able to achieve a desirable performance. It's also intended for those laboratories that, for whatever reason, lack of resources, etc., are not able to achieve a desirable performance. A desirable performance goal is defined as the most widely accepted and frequently used quality specification. The optimum performance goal is intended for those tests for which desirable performance is easily obtained. This is a stretch goal. Using the formulas suggested by Dr. Fraser, allowable imprecision is calculated where CVA represents total allowable imprecision, and CVW represents within subject biological variation as published. The last component we need for our equation is our bias goal %. To calculate the bias goal %, there are two pieces of information that are needed: published biological variation data, both within subject and between subjects, the performance goal for bias that the laboratory wants to achieve. If we were to choose a performance goal for imprecision of desirable, and the published CVW is 5.7%, then the CVA would be 2.85%. We already know where we can go to retrieve the biological variation data, so we'll move on to choosing a performance goal for bias. We have the same three performance goals to choose from for our bias goal: minimum, desirable, optimum. Using formulas suggested by Dr. Fraser, allowable bias is calculated as shown, where BA represents total allowable bias, CVW represents within subject biological variation data, and CVB represents between subject variation. If we were to choose a performance goal for bias of desirable, and the published CVW is 5.7%, and the CVB is 6.9%, then the BA would be 2.24%. We have all the information we need to calculate the TEA. We'll multiply the z-score, 1.65, by the CVA, 2.85%, and then add the BA, 2.24%, resulting in a TEA of 6.94%. We determined that the TE for the test is 10.1% and that the TEA is 6.94%. To ensure we're in budget, the TE cannot exceed the TEA. In this example, the TE exceeds the TEA, so it's clear the laboratory is failing to meet the quality specifications for the test. To help troubleshoot the testing procedure, we can use the actual values for imprecision and bias and compare them to the selected goals. In our example, both imprecision and bias are not meeting the desired level of performance, and therefore both need to be improved to meet quality specifications. Let's review what we've learned about TEA. The formula for calculating TEA is z-score times imprecision goal percent plus bias goal percent. Two locations to determine if biological variation data exists for a test are Appendix 1 of Dr. Callum Fraser's book, Biological Variation from Principles to Practice, the Biological Variation Database hosted on Dr. Westgard's website. The database is maintained by Dr. Carmen Ricos and her colleagues. Performance goals are defined by Dr. Callum Fraser: minimum, for tests unable to meet desirable performance; desirable, most widely accepted and used goal; optimum, intended for tests for which desirable performance is easy to obtain. For a test to be within quality specifications, the TE must be less than the TEA. Actual values for imprecision and bias can be compared to the laboratory's selected goals to help identify where reasoned troubleshooting is needed. For all of your laboratory QC needs, go to www.qcnet.com.